Let's learn about functional patterns. Functional programming is very useful because it usually expresses solutions in a very direct way. This allows us to focus on high-level details rather than low-level implementation concerns. When we treat functions as values, we can pass them as arguments to other functions. These other functions will then call the function argument. This is the key insight for functional programming. Let's revisit a few patterns with this new ability. Our first patterns do not actually use functions as values. Previously, to calculate a sum, count, minimum, or maximum, we used for loops. Now we can do each with a single function call. The sum, len, max, and min functions each consume lists and return a single number. The map function consumes a function and a list, applies the function to each element of the list, and returns a new list. The function that it consumes should take a single argument, which will represent a single element of the list. This pattern is almost identical to the one we saw when we learned about for loops. The filter function consumes a Boolean function and a list, applies the function to each element to determine if it should be kept, and returns a new list. Like the map function, the function consumed should itself consume a single argument that will represent a single element of the list. However, that function needs to return a Boolean value. A new pattern we have not seen before is sorting. Computer science has dedicated decades of its finest minds to understanding and optimizing sorting. However, for our purposes, all we need to know is we can pass in a list and a key function, and get the list back sorted. If you do not pass in the key function using a name parameter, the list is sorted as it naturally would. For integers, this means low numbers in the front and higher numbers in the back. A key function can be used to have Python treat each element differently. The example shown here flips positive numbers to negative, making the list get sorted in reversed order. Notice that the key function is only used for sorting. It does not change the values in the list like map does. If you try running the examples above in IPython, you will see confusing output, like the one in the top right. This is an example of an iterator object. An iterator is very similar to a list, but has certain performance benefits. For our purposes, you can see the data inside an iterator by converting it to a list. This is only an issue if you are programming outside of BlockPy.